Everyone, so today's topic is expression for electrical conductivity in applied physics for EEE stream. So what is electrical conductivity? Electrical conductivity is a measure of the ability of a substance to allow the flow of an electrical current. So metal and plasma are examples for materials with high electrical conductivity. The element that is best electrical conductor is silver, which is a metal, and electrical insulators such as glass and pure water have very poor electrical conductivity. And the ability of the materials to pass electricity through them is known as conductivity. Depending on the conductivity, materials are classified as conductors, insulators, and superconductors. So in conductors, there is no band gap, and when we look into semiconductors, there is a narrow band gap which is of like 1 electron volt, and in insulators there is wide band gap which is of apparently 5 electron volt. So electrical conductivity. Electrical conductivity of a material is usually expressed using the formula sigma is equals to IL divided by AV, where I is the electric current passing through the material, and L is the length of the material through which the current flows. E is the cross-sectional area of the material perpendicular to the current flow, and V is the voltage applied across the material. Relates the current voltage, length, and cross-sectional area to the material's electrical conductivity. It is commonly used in engineering physics to quantify a material's ability to conduct electric current. And when we look into environmental significance of electrical conductivity, so electrical conductivity measurements are often employed to monitor desalination plants. It is useful to access the source of pollution. In coastal regions, conductivity data can be used to decide the extent of intrusion of sea water into groundwater. And conductivity data is useful in determining the suitability of water and wastewater for disposal on land. Used indirectly to find out inorganic dissolved solids. So this is the expression for electrical conductivity, and electrical conductivity is defined as the rate of change flow across unit area in conductor per unit potential gradient. So that is sigma is equals to J divided by I. Its unit is Ohm inverse meter inverse. Expression for electrical field is applied to an electron of charge E of a metal rod. The electron moves in opposite direction to applied field with the velocity vt. The velocity is known as drift velocity. So Lorentz force acting on the electron is F is equals to EE, which we'll take this as equation 1. So this force is known as the driving force of the electron. Due to this force, the electron gains acceleration A. From Newton's second law of motion, force is equals to ma, which we will take as equation 2. From the equation 1 and 2, we'll get ma is equals to ee, or a is equals to ee divided by m, which we will take as equation 3. So acceleration is equals to drift velocity divided by relaxation time, or a is equals to vd by t, and vd is equals to a into t, which we'll take this as equation 4. So when we substitute equation 3 in 4, we'll get vd is equals to et divided by m whole multiplied into e, which is equation 5. The Ohms law states that current density is expressed as J is equals to sigma E, or sigma is equals to J divided by E, which is equation 6, where sigma is the electrical conductivity of an electron, but the current density in terms of drift velocity is given as J is equals to NEVD, which we will take as equation 7. So when we substitute 5 in equation 7, we get J is equals to NE into ET divided by M whole multiplied into F. So sorry, divided by E minus any square T divided by M, which will take as equation 8. On comparing the equations 5 and 8, we have electrical conductivity as sigma is equals to any square T divided by M. And thank you for watching.